2009 চনৰ পৰা এটা দশকতকৈও অধিক কাল ধৰি অনুষ্ঠিত হৈ অহা ৰিপুঞ্জয় তামুলী ফুৰণি বক্তৃতানুষ্ঠান এইবাৰ বিশেষ পৰিস্থিতিৰ বাবে প্ৰথমবাৰৰ বাবে অনলাইন যোগে অনুষ্ঠিত কৰা হৈছে। এইবাৰৰ বক্তৃতানুষ্ঠানৰ বিষয় হৈছে ফাইণ্ডিং এফিচিয়েণ্ট ৰুটছ ইন দ্য ৱৰ্ল্ড ফ্ৰম ৰুটছ টু দ্য ইণ্টাৰনেট। বক্তৃতা প্ৰদান কৰিব প্ৰফেচাৰ দীপংকৰ মেধি। তেওঁ হৈছে ইউএছএৰ নেশ্যনেল ছায়েন্স ফাউণ্ডেশ্যনৰ প্ৰগ্ৰেম ডিৰেক্টৰ আৰু কিউৰেটৰ্ছ ডিষ্টিংগুইছড প্ৰফেচাৰ অৱ ইউনিভাৰ্চিটি অৱ মিছৌৰী কেনচাছ চিটি। Keynote address by Dr. Manavendra Sahuria of IIT Delhi.
प्राप्नोति मोक्षं चितो तं श्रीरामहं महिषावरदं वन्दे सदा सादरामि।
जय जय रघुकुल अमल प्रकाशक दासक नाशक इति। जय जय रघुकुल अमल प्रकाशक दासक
An image, if curated well, can convey an idea or emotion worth more than 1,000 words. The portion short video clip, Destiny, in itself speaks volume of how Ripunjoy Knowledge Hub came into existence and what significance this day and this memorial lecture holds. So without further ado, I, Ms. Sibasri Hodesa, Assistant Professor, Department of Geology, along with my co-host, Ms. Antaripa Bora, Assistant Professor, Department of Education, Biswanath College, Assam, on behalf of the Biswanath College fraternity, feels privileged to extend our warm welcome to our respected resource person of today's event, all honorable dignitaries, and also to all the attendees of today's memorial lecture on finding efficient route in the world from road to internet. With this, we shall now begin today's event with a traditional lamp lighting ceremony. And to do the honor, I would like to call upon our respected principal of Biswanath College, Dr. Sintamani Sharma sir. Before we begin, may I request all the attendees of the program to mute their mic and video. Thank you so much.
Thank you, sir, for doing the honor. অনুষ্ঠানটো আৰম্ভ কৰাৰ আগতে মই ইয়াতে এটা কথা জনাব বিচাৰিছো যে এই অনুষ্ঠানত সদায় দেখি থকা এখনি মুখ আৰু আমি কোনোদিনে দেখিবলৈ নাপাওঁ। এই মহাবিদ্যালয়ৰ পদাৰ্থ বিজ্ঞান বিভাগৰ অৱসৰপ্ৰাপ্ত মুৰব্বী অধ্যাপক শ্ৰীযুত তুলেশ্বৰ নাথ ছাৰ এই বছৰৰ 19 অক্টোবৰ তাৰিখে আমাৰ মাজৰ পৰা চিৰদিনৰ বাবে আঁতৰি গ'ল। আজিৰ এই পবিত্ৰ মুহূৰ্তত ছাৰৰ প্ৰতি আমি শ্ৰদ্ধা প্ৰণাম জনাইছো আৰু আজিৰ এই অনুষ্ঠানটি ছাৰৰ নামত উৎসৰ্গা কৰিছো। প্ৰতি বছৰে আমি এই অনুষ্ঠানটো এটি বৰগীতৰেৰে আৰম্ভ কৰি আহিছো আৰু আজিও এই পৰম্পৰা ৰক্ষা কৰি শংকৰদেৱ বিৰচিত কেদাৰ ৰাগৰ এটি সুন্দৰ বৰগীতেৰে আৰম্ভ কৰিবলৈ ওলাইছো। প্ৰতি বছৰে এই বৰগীতটি বিশ্বনাথ মহাবিদ্যালয়ৰ শ্ৰেষ্ঠ গায়ক বা গায়িকাই পৰিৱেশন কৰি আহিছে। এইবাৰো এই পৰম্পৰা আগবঢ়াই লৈ যাব আমাৰ এসময়ৰ শ্ৰেষ্ঠ গায়িকা জ্যোতিমালা বুঢ়াগোহাঁই।
হরি হরি করো কাতরি প্রাণ রাখবি মোর প্রাণ রাখবি মোর প্রাণ রাখবি মোর।
Now, I would like to request our respected principal, sir, Dr. Sintamani Sharma, sir, to address the gathering with a welcome speech.
সকলোকে আমাৰ ৰিপুঞ্জয় নলেজ হাবত আজি ৰিপুঞ্জয় তামুলী পৰিয়াল ট্ৰাষ্টৰ উদ্যোগত আয়োজিত বছৰীয়া বক্তৃতা অনুষ্ঠানত আমি স্বাগতম জনাইছোঁ। ৰিপুঞ্জয় নলেজ হাব বিশ্বনাথ চাৰিআলিৰ বিশ্বনাথ কলেজত অৱস্থিত। এই কেন্দ্ৰটোৰ বিষয়ে সামান্যকৈ মই দুটামান কথা আপোনালোকৰ আগত নিবেদিব বিচাৰিছোঁ। আমাৰ মহাবিদ্যালয়ৰ প্ৰাক্তন ছাত্ৰ যাক আমি অকালতে হেৰুৱাবলগীয়া হৈছিল, ৰিপুঞ্জয় তামুলীৰ সোঁৱৰণত তেওঁৰ স্মৃতি আমি যাতে যুগমীয়া কৰি ৰাখিব পাৰোঁ, এই উদ্দেশ্য আগত ৰাখি তেখেতৰ পিতৃ শ্ৰদ্ধাৰ ভাৰত চন্দ্ৰ তামুলী ডাঙৰীয়া আৰু তেওঁৰ মাতৃ বৰ্তমান আমাৰ মহাবিদ্যালয়ৰ প্ৰাণীবিজ্ঞান বিভাগৰ মুৰব্বী অধ্যাপিকা জ্যোতিকণা দাস তামুলী দুয়োৰে উদ্যোগত এই কেন্দ্ৰ ইয়াত স্থাপন কৰা হৈছে। অতি আটক ধুনীয়া কেন্দ্ৰ স্থাপন কৰা হৈছে। তেখেতসকলে মহাবিদ্যালয়কে যাতে মহাবিদ্যালয়খনে আমাৰ উঠি অহা চামক যুৱ প্ৰজন্মক বিদ্যায়তনিক দিশত আন দিশত যাতে উদ্বুদ্ধ কৰিব পাৰে, কেৱল এই কেন্দ্ৰটো একাডেমিক এক্টিভিটি কৰিবৰ বাবে তেখেতসকলে কলেজলৈ উৎসৰ্গা কৰিছে। 2009 চনৰ 25 নৱেম্বৰ তাৰিখে আনুষ্ঠানিকভাৱে মহাবিদ্যালয়লৈ এই কেন্দ্ৰ তেখেতসকলে উপহাৰ দিছিল। ঠিক তাৰ এক বছৰ পিছতে 2010 চনৰ 25 নৱেম্বৰ তাৰিখে আমি অতিশয় সুখী যে কটন মহাবিদ্যালয়, বৰ্তমান বিশ্ববিদ্যালয়, তদানীন্তন কটন মহাবিদ্যালয়ৰ অৱসৰপ্ৰাপ্ত অধ্যক্ষ প্ৰফেসৰ ডি.কে. বৰুৱাদেৱে ফিলচফি এণ্ড ইকনমিক্স অফ অমৰ্ত্য কুমাৰ সেন এই বিষয়ত তেখেতৰ তত্ত্ববধুৰ বক্তব্য দাঙি ধৰিছিল। সেয়া আছিল আমাৰ প্ৰথম বছৰ পূৰ্তি হওঁতে আমি কৰা এনুৱেল লেকচাৰ ছেশ্যন। ঠিক তাৰপিছত আমি 25 নৱেম্বৰ 2011ত আমি দ্বিতীয়বাৰৰ বাবে তেজপুৰ ইউনিভাৰ্চিটিৰ প্ৰ' ভাইচ চেঞ্চেলৰ অমৰজ্যোতি চৌধুৰী ছাৰক নিমন্ত্ৰণ জনাই এই কেন্দ্ৰতে আমি নেনো ছায়েন্সৰ ওপৰত আমি বক্তৃতা প্ৰদান কৰাৰ এটা ব্যৱস্থা কৰিছিলোঁ ৰিপুঞ্জয় নলেজ হাবৰ যোগেদি। ঠিক তেনেদৰে আমাৰ সৌভাগ্য বুলিয়ে ক'ব লাগিব, অসমৰ এগৰাকী বিশিষ্ট চিন্তাবিদ, সাহিত্যিক, বুদ্ধিজীৱী ডক্টৰ বীৰেন্দ্ৰনাথ দত্তদেৱৰ লোক সংস্কৃতিত বহুমাত্ৰিক আত্মসংযোগ, মাল্টি ডাইমেনশ্যনেল ইণ্টাৰকানেকশ্যন ইন ফ'ল্ক কালচাৰ, এই বিষয়ত এক তত্ত্ববধুৰ বক্তব্য দাঙি ধৰিছিল। তেনেদৰে আমি 13 চনত শিল্পী বীৰেন সিঙক নিমন্ত্ৰণ জনাইছিলোঁ। জীৱন আৰু শিল্প বিষয়ত তেখেতে এই বিষয়ৰ ওপৰত বিস্তৃতভাৱে বক্তব্য আগবঢ়াইছিল। 14 চনত আমি আকৌ ডক্টৰ পদ্মপাণি ছাৰৰ দ্বাৰা ফৰেন্সিক বিজ্ঞান, যুৱ প্ৰজন্মৰ অপৰাধ প্ৰৱণতা আৰু মূল্যবোধৰ অৱক্ষয়, এই শীৰ্ষক বক্তৃতামালাৰ আমি আয়োজন কৰিছিলোঁ। তাৰ 15 চনত আমি উল্লেখযোগ্য দিন বুলি ক'ব লাগিব। সেইদিনাখন আসিফ ইব্ৰাহিমৰ দ্বাৰা প্ৰণীত লাভ ফৰ লাইফ নামৰ গ্ৰন্থখন তাত উন্মোচন কৰিছিল বিশিষ্ট লেখক দেৱব্ৰত দাস ডাঙৰীয়াই। আৰু সেই বছৰৰ আমাৰ বছৰীয়া যি বক্তৃতামালা আছিল, বিশিষ্ট সাংবাদিক মৃণাল তালুকদাৰ ডাঙৰীয়াই মি মাৰ্কেট এণ্ড মিডিয়া দ্য ৱৰ্ল্ড ফ্ৰম হুৱেৰ ইউ কেনট স্কিপ এই বিষয়ৰ ওপৰত বক্তব্য ৰাখিছিল। তেনেদৰে আহি আমি যেতিয়া 2016 চনত পালোঁ, গুৱাহাটী বিশ্ববিদ্যালয়ৰ ইংৰাজী বিভাগৰ প্ৰাক্তন মুৰব্বী অধ্যাপক ডক্টৰ ৰঞ্জিত কুমাৰ দেৱগোস্বামীদেৱে বৌদ্ধিক ইতিহাস পৰিচয় চৰ্চা আৰু বিস্তৃতি এই সংক্ৰান্তত তেখেতে নিজৰ বক্তব্য আগবঢ়াইছিল। 2017 চনত ডক্টৰ চন্দন মহন্ত তেখেত ডিন ষ্টুডেণ্ট এফেয়াৰ্ছ এণ্ড প্ৰফেচৰ চেণ্টাৰ ফৰ এনভাইৰনমেণ্ট এণ্ড ডিপাৰ্টমেণ্ট অফ এনভাইৰনমেণ্ট ইঞ্জিনিয়াৰিং IIT গুৱাহাটী তেখেতে হেল্ডি লুইথ হেপ্পী অসম ফ্ৰম হাইড্ৰ ডিজাষ্টাৰ টু হাইড্ৰ ফিলচফি এই বিষয়ত তেখেতে খুব সুন্দৰ বক্তৃতা আগবঢ়াইছিল। আমি আহি যেতিয়া 2018 চনত পালোহি, এতিয়া ডক্টৰ অঞ্জন জ্যোতি ভাৰ্গৱ তেখেত ৰেজিষ্ট্ৰাৰ অফ মেডিচিন গুৱাহাটী মেডিকেল কলেজ এণ্ড হস্পিটেল তেখেতৰ দ্বাৰা জেৰিয়াট্ৰিক কেয়াৰৰ বিষয়ে বক্তৃতাৰ আয়োজন কৰা হৈছিল। আৰু যোৱা বছৰ 2019 চনত আমি এই 10 বছৰ জোৰা আমি যিখিনি কাৰ্যসূচী ইয়াত সম্পাদন কৰিলোঁ, মই কেৱল বছৰীয়া বক্তৃতাৰ কথাখিনিয়ে মই উল্লেখ কৰিছোঁ। বিভিন্ন শৈক্ষিক বিদ্যায়তনিক আমাৰ কাৰ্য ইয়াত অনুষ্ঠিত হৈ গৈছে। এই গোটেইখিনিক সমাৱেশ কৰি জাৰ্নি অফ ওৱান ডিকেড এটা দশকৰ পৰিভ্ৰমণ যি জাৰ্নি অফ ওৱান ডিকেড শীৰ্ষক গ্ৰন্থ ৰিপুঞ্জয় নলেজ হাবৰ দ্বাৰা ইয়াত তৃতীয় বিশ্বনাথ জিলাৰ উপায়ুক্ত ধ্ৰুৱজ্যোতি দাস মহোদয়ৰ দ্বাৰা উন্মোচন কৰোৱা হৈছিল। আৰু এই গ্ৰন্থখন এই কাৰণে উল্লেখ কৰিবলগীয়া যে এই 10 বছৰ পৰিক্ৰমাত আমি যি ব্যক্তিসকলক বিভিন্ন বিষয়ৰ ওপৰত আহি বক্তৃতা দিয়াৰ আমি এটা ব্যৱস্থা কৰিছিলোঁ, তেখেতসকলৰ সেই যিখিনি বক্তৃতা দিছিল, বক্তৃতাৰ গোটেই পত্ৰখিনি আমি সমাৱেশ কৰি এক গ্ৰন্থ আকাৰে তাক প্ৰকাশ কৰি উলিয়াইছোঁ। আৰু যোৱা বছৰে আমাৰ বিকাশ কলিতা সকলোৱে জানে, তেখেত মটিভেশ্যনেল কোচ, চাৰ্টিফাইড কোচ আৰু মটিভেশ্যনেল স্পিকাৰ, চাৰ্টিফাইড কোচ এণ্ড লাইফ স্কিল ট্ৰেইনাৰ। তেখেতে এ নিউ ইউ এক নতুন আপুনি শীৰ্ষক বিষয়বস্তুৰ ওপৰত খুব সুন্দৰকৈ বক্তৃতা প্ৰদান কৰিছিল যোৱা বছৰ। আৰু ঠিক এই বছৰ আমি সেই 10 বছৰৰ কথা কৈছোঁ, সেই 10 বছৰত আমি ফিজিকেল আমাৰ পোনপটীয়াকৈ প্ৰত্যক্ষভাৱে আমি সভা পাতি বক্তৃতাৰ আয়োজন কৰিছিলোঁ। বিভিন্ন ব্যক্তিক আমি ইয়াত নিমন্ত্ৰণ কৰিছিলোঁ। কিন্তু বৰ্তমান যি কৰোনাৰ ভয়াৱহতা, সেইটো এতিয়াও খাম কটা নাই। গতিকে আমি দেখিলোঁ যে আমি এনেদৰে একেটা মঞ্চত আমি সকলোকে লগ খুৱাই আমি এই অনুষ্ঠান আয়োজন কৰিব নোৱাৰিম। গতিকে আমি ভাৰ্চুৱেল সেমিনাৰৰ দ্বাৰা, পাৱাৰ সেমিনাৰৰ দ্বাৰা সকলোৱে যাতে উপকৃত হয়, সেইবাবে আজি এই বছৰীয়া যি আমি ইয়াত বক্তৃতাৰ আয়োজন কৰিছোঁ, তাৰ আজিৰ থিম হৈছে ফাইণ্ডিং এফিচিয়েণ্ট ৰুটছ ইন দ্য ৱৰ্ল্ড ফ্ৰম ৰুটছ টু দ্য ইণ্টাৰনেট। আমি সঁচাকৈ সৌভাগ্যৱান বুলি এইকাৰণে ক'ম, বিশ্বনাথ কলেজৰ আমি ৰিপুঞ্জয় নলেজ হাবৰ লগতে বিশ্বনাথ মহাবিদ্যালয়ৰ পৰিয়ালৰ সকলো সদস্য এইকাৰণে আমি সৌভাগ্যৱান বুলি ক'ম যে আমাৰ অসমৰে এগৰাকী সুযোগ্য সন্তান প্ৰফেচৰ দীপাংকৰ মেধি, তেখেত এতিয়া মিছৌৰী ইউনিভাৰ্চিটি USAৰ কিউৰেটৰ আৰু তাৰে আকৌ নেশ্যনেল ছায়েন্স ফাউণ্ডেশ্যনৰ তেখেত সঞ্চালকো। তেখেতে আমাৰ অনুৰোধ ৰক্ষা কৰি এই বিষয়বস্তুৰ ওপৰত তেখেতে আমাৰ এই বছৰীয়া যি বক্তৃতা অনুষ্ঠান, সেই বক্তৃতা অনুষ্ঠানত তেখেতে আমাক উপকৃত কৰিবৰ বাবে, উৎসাহিত কৰাৰ বাবে যি সন্মতি প্ৰদান কৰিলে আৰু ইতিমধ্যে তেখেতে আমাৰ মাজত যোগদান কৰিছেহি। মই অধ্যাপক দীপাংকৰ মেধি ডাঙৰীয়াক উষ্ণ আদৰণি জনাইছোঁ আমাৰ ৰিপুঞ্জয় নলেজ হাব লগতে আমাৰ মহাবিদ্যালয় মজিয়াৰ পৰা। ঠিক তেনেদৰে আমাৰ দিল্লী IITৰ আন এগৰাকী অসমৰ এগৰাকী সুযোগ্য সন্তান অধ্যাপক মানৱেন্দ্ৰ চহৰীয়া, তেখেতে আজি এই বিষয়বস্তুৰ ওপৰত কিনোট এড্ৰেছ এটা দিব। আৰম্ভণিৰ সাৰাংশখিনি তেখেতে দাঙি ধৰিব। তেখেতকো আমি আমাৰ ৰিপুঞ্জয় নলেজ হাব আৰু বিশ্বনাথ চাৰিআলিৰ বিশ্বনাথ কলেজৰ এই মজিয়াৰ পৰা তেখেতক আমি উষ্ণ আদৰণি জনাইছোঁ। স্কটিছ নভেলিষ্ট, কবি আৰু ৰাইটাৰ এগৰাকী ৰবাৰ্ট লুইচ ষ্টিভেনছন, তেখেতে এটা কথা কৈছিল, ডোণ্ট জাজ ইচ ডে বাই দ্য হাৰ্ভেষ্ট ইউ ৰিপ, বাট বাই দ্য চিডছ ইউ প্লান্ট। সঁচাকৈয়ে বিশ্বনাথ মহাবিদ্যালয়ত ৰিপুঞ্জয় নলেজ হাব নামৰ যি চিড আমি ৰোপণ কৰিছোঁ, এই ৰোপণে কিন্তু অনাগত দিনত আমাৰ বিশেষকৈ যুৱচামক বিদ্যায়তনিক দিশত নিজৰ জীৱন ক্ষেত্ৰত আগবাঢ়ি যোৱাৰ ক্ষেত্ৰত আৰু বিভিন্ন জ্ঞান আহৰণ কৰাৰ ক্ষেত্ৰত নিশ্চয়কৈ এক মাইলৰ খুঁটি হৈ ৰ'ব, নিশ্চয়কৈ অৰিহণা যোগাব। মই আজি আমাৰ এই বছৰীয়া ৰিপুঞ্জয় নলেজ হাবৰ বক্তৃতা অনুষ্ঠান আছে, সেই অনুষ্ঠানত অংশগ্ৰহণ কৰা সকলোকে আদৰণি জনাইছোঁ আৰু উল্লেখ কৰিব লাগিবই আমাৰ ৰিপুঞ্জয় তামুলীৰ পিতৃ শ্ৰদ্ধাৰ ভৰতচন্দ্ৰ তামুলী ডাঙৰীয়া আৰু তেওঁৰ মাতৃ অধ্যাপিকা জ্যোতিকণা দাস তামুলীৰ যি প্ৰচেষ্টা, তেখেতসকলৰ অহোপুৰুষাৰ্থৰ বাবে আৰু তেখেতসকলে যিমান সুন্দৰকৈ এই অনুষ্ঠান আগবঢ়াই হোৱাৰ বাবে আমাৰ মহাবিদ্যালয়ক উৎসাহ যোগাইছে, সকলো সময়ত আমাৰ লগত লগ দিছে, তেওঁলোকক মই তেওঁলোকৰ এনেধৰণৰ যোগাত্মক কথাৰ শলাগ লৈছোঁ। অৱশেষত সকলোকে এই অনুষ্ঠানত অংশগ্ৰহণ কৰাৰ বাবে মই ধন্যবাদ জনাইছোঁ আৰু সকলোকে মই স্বাগত অভিনন্দন। ধন্যবাদ।
Thank you, sir, for your enlightening words. Moving further, on this auspicious occasion, we feel honored to have among us one of the most highly talented and dynamic scientists of today's time. A man of distinct vision and a fountainhead of illuminating ideas, Dr. Manabendra Saharia, sir. Dr. Manabendra Saharia will be delivering the keynote address for today's memorial lecture. On behalf of the Viswanath College family, I wish to extend my heartiest welcome to you, sir, for gracing today's program with your presence. Dr. Manabendra Saharia is currently working as an assistant professor in the Department of Civil Engineering, IIT Delhi. He did his MS and PhD in Water Resources Engineering from the University of Texas at Arlington and University of Oklahoma, USA. He has the expertise on flood forecasting, land surface modeling, weather and satellite precipitation, statistics, machine learning, human computation. He has been working as a researcher in the NASA Goddard Space Flight Center, USA. He has also been working on the viabilities of flood mechanism systems in our region, which includes the formation of a Northeast Open Data Consortium. Manabendra Saharia, sir, has made all the fellow citizens proud by being selected to work in the prestigious National Aeronautics and Space Administration NASA organization of USA. However, his dream was not just limited to work in the world's top space research organization and announced his decision to quit his job and come back to India, teach and guide the young engineers and scientists of his homeland. Sir, you have made all of us proud by your distinguished work in numerous capacities. Once again, we welcome you, sir, and now I hand over the session to you.
Hello, everyone. Am I audible?
Yes.
Yes, sir.
Okay.
Sir.
Thank you so much. মোৰ আজিৰ বক্তব্যখিনি মই ইংৰাজীতে ৰাখিম, তাৰ বাবে আগতীয়াকৈ মই ক্ষমা বিচাৰিছোঁ। Very warm good evening to everyone, and thank you for the very generous introduction, and I think it could have been a lot shorter, but thank you very much. Before anything, I would like to thank the entire organizing team behind Ripunjoy Knowledge Hub and everyone from Viswanath College who is involved. A few months back, I think it was 2 months back, when Bharat Chandra Tamuly Dangoria approached me regarding this speech, And till that time, I was actually not aware of Ripunjoy Hub at all. And when I received the doc, he sent me a very nice book, and I read through a couple of speeches, and I was very impressed to hear that this initiative has been running successfully for more than a decade now. My personal experience is that I think it is very easy to start new things, but it takes tremendous amount of vision, execution, and determination to build like generational knowledge over a long period of time. And I think this is the kind of initiative that I think more of what Assam needs, and we will see it in more colleges as well. So it is my great fortune that you have asked me to become a small part of it, although virtually for today and hopefully in person someday. Today we have amongst us Professor Deep Mehdi, who is as mentioned, he's the Curator's Distinguished Professor of Computer Science and Electrical Engineering at the University of Missouri, Kansas City. He has a rather long list of accomplishments to his name that I will not list out. Apart from mentioning two things, that he is a fellow of IEEE, a distinguished organization of electrical engineers worldwide. And more importantly, he is the program director of Computers and Network Systems Division of the National Science Foundation. And his position is in a unique position and experience that allows him to have a very big picture view of the field that we are hoping to learn from today. So today he's going to be introducing a topic to us that I think is fundamental to not just computational science. Of course, Professor Mehdi will speak from his perspective, but I think what he's going to be talking about is kind of fundamental to human evolution and progress itself. I'm not going to give out too much of his talk, but he is going to talk about efficiency. In day-to-day life, generally we consider how much of this word efficiency is underlying the economic and the social engine of the world. Much of our life is based on how we can find optimal ways of accomplishing a particular task. Now, even if we take one step backwards and ponder over a simple question, how did humans become the most dominant species on this planet? Now, consider for a moment that human beings are not the biggest species on the planet. In fact, we are not even the biggest species in the primate order. We are far from being the fastest. Plenty of animals are faster than us. But humans have become the most dominant species because of its ability to optimally burn energy, not just as a part of the brain, but also overall in our body. In fact, humans are one of the best endurance runners in the animal kingdom. And before we domesticated animals, humans were fierce persistence hunters. So persistence hunting would imply that we would hunt stronger animals, often for long days, until a faster or stronger animal just collapses on the ground out of exhaustion. In fact, even today, there are certain tribes in sub-Saharan Africa who continue to practice persistence hunting. And I think that is one of the finest examples of efficiency over thousands and thousands of years. When we as a species, or our forefathers, were trying to accomplish one task as a species, that is finding food, then all we needed was to develop a more efficient way of burning energy while going from point A to point B. I think this urge for efficiency continues throughout our history. You can almost write a book on efficiency in our human history, because much of the scientific invention, much of what we now recognize as human culture, is because of our need and want to find optimal trade routes, starting from the original, when Arabs tried to find a shorter route, or even the Europeans tried to find a shorter route to Asian subcontinent for spices. So it is another example of where efficiency continues to dominate human imagination. Professor Mehdi today will help us navigate a different world, the digital world, and I think how humanity's search for efficiency continues in this medium, and in a medium that now permeates all parts of human life. So without further ado, I would like to now welcome Professor Mehdi to take over the center stage and enlighten us from his vast experience in this field. Thank you very much.
Thank you so much, Dr. Manavendra Sahari, sir, for enlightening us with the importance and relevancy of the topic in relation to our day-to-day life. Now, we have reached to the main agenda of our memorial lecture, and we are profusely elated to introduce before you our resource person of today's lecture, an eminent personality, a brilliant mind, an idol of knowledge and experience, and an inspiration to us all, Professor Dipankar Medi, sir. Sir, we are honored to have you here with us today, and on behalf of Biswanath College family, would like to welcome you and thank you for providing your gracious presence. Professor Dipankar Modi, sir, who is a renowned Indian-American computer scientist and inventor, had a humble beginning with the bachelor degree in mathematics from Cotton College, Guwahati University, Assam in the year 1983, master degree in mathematics from St. Stephen College, Delhi University in the year 1983, and MS and PhD in computer sciences from University of Wisconsin, Madison in the year 1985 and 1987. Currently, Professor Dipankar Medi is serving as a program director in the Computer and Network Systems Division at National Science Foundation, and is also a curator distinguished professor in the Department of Computer Science and Electrical Engineering at University of Missouri, Kansas City. His research interests include network resilience, network routing and optimization, reconfigurable networks and network virtualization, traffic engineering, network management, network testbeds and experimentation, data center networking, and video quality of experience. Professor Dipankar Medi has also published over 170 peer-reviewed papers and is co-author of books, which has been both published by Morgan Kaufman as a dear. Prior to joining University of Missouri, Kansas City, he worked as a technical officer at AT and T-Bell Laboratories, routing and designing teletraffic networks, where he co-invented the facility diverse routing system. Professor Dipankar Medi is also a recipient of many honorable and distinguished awards, and he is a fellow in Institute of Electrical and Engineering, IEEE, for his scientific contribution to optimizing and the design of computer communication networks. Sir, you are an inspiration to us, and we feel pride and honor to welcome you here among us today. Before moving on, I would like to request all the attendees to mute their mic and videos during the lecture, and would also like to inform you all that the memorial lecture will be followed by a short Q&A session, and so the attendees can state their question in the chat box and also mention their respective name and designation. Only those questions relevant to the topic will be addressed. So I would like to hand over to the session to our respected speaker of the event, Professor Dipankar Medi, sir. Sir, over to you.
Very much. Thank you for a great introduction. And মই অসমীয়াত অলপ কম মাজে মাজে, কিন্তু mostly গোটেই প্ৰেজেণ্টেশ্যনটো মই ইংৰাজীত দিম। First, I'd like to thank Mr. Chandra Tamuly Damoria and Dr. Jyotikuna Das Tamuly for inviting me to give this presentation. I'm truly honored for being considered to give this. I wish I was there in Biswanath college today, and hopefully I'll be there someday when I'm next time in India after the coronavirus situation gets better. I also like to thank Dr. Sintamani Sarma, the principal, for his welcome address, and my young friend Dr. Manavendra Sahari for his keynote, and he talked a lot of interesting stuff. In fact, that would have been a keynote in itself, or presentation in itself, and more interesting, and to also listen about the human kind and where we are going. So I do have a presentation slides, and so I'm going to go through the slides, and I at the same time I don't use the slides to make it extremely formal. I am a very informal way of talking, and so that's what I'm going to do. And I hope you don't mind. Once in a while, I'll sip water because I need to drink something to keep my mouth dry. So that's okay with you. And let's see. And then I am going to switch over to my presentation, and let's see. Give me a sec. Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. Okay. As was requested, please mute yourself, and there will be time for question and answers. অসমীয়াতে সুধিব পাৰে, যেতিয়া প্ৰশ্ন সুধিব কৰে বা টাইপ কৰিলেও হ'ব। গতিকে সেইফালৰ পৰা there is no problem with that. And I try to do a sort of a way to look at a problem that has some sort of an interdisciplinary nature. So I'm going to go with that. And first, I'm going to put something out on the slide, but I'm not going to read it. I purposefully put it there. I was trying to see if they could set up a poll in the WebEx for this one, and that you select, you have two options to select. I don't know if they were able to set it up. If they did, and I'll come back to this at the end of the talk. All right. So, and I'm not going to read that. The reason why I don't read it, and you'll find it later. So I'm going to start with distance. So what, I mean, we kind of say what's in a name, of a way to look at the idea of what I call as a distance. So what if you think of this that we are familiar with from our very young days, about that I have 2 points and I actually want to connect it, and somebody say, what's the shortest way to connect those 2 points? And we say that, you know, it's a straight line, and you actually connect it that way, and that's what it is. Now, let's say, is that always true? That's the first question, you know, going beyond what we are in an early stage in our life. What happens if we change something about it? Let's see. What I did here is that I put a globe there, as you can see, and I purposefully picked Biswanath Sariyali here. Hopefully you can see that with my my cursor here, and I picked Paris here on the other end. And you want to go from, say, Biswanath Sariyali to Paris. And if you want to go on this globe, you're actually going to go what looks like a curve, actually, because it's a circle, right? And so you cannot actually go through directly in a straight line, because you have to completely dig it to be able to go there. So the same thing about, I have a cricket ball in my hand, and you can see that if I pick 2 points on my 2 points, what's the shortest on the same, and you said that I have to go on the top to get to this other side, unless I make it completely a hole. So the shortest distance is not always a straight line. That's a very interesting way to kind of think about, is that if you change the context of a problem, it actually changes how you look at it. Before I go forward, I want you to make a note. This might be helpful to you at the end if you're asking a question. At the bottom right corner, I have the page number of the slide. So you can say that, oh, I have a question about page number 4 or 10 or whatever. Then you can actually bring it up, and I'll be happy to go back to that about that one. So, all right. So that's good. Now let's look at something from a simple principle from geometry, and you don't have to remember your geometry from when you learned it in school. But one simple thing we all know is what is called is that we call it actually known as a triangular inequality. It says that the sum of 2 sides is actually larger than the third side of the triangle. So here's a picture. I put a right angle triangle here. Any triangle will be fine. If I do A plus B, it is bigger than the third side C. Similarly, if I do A plus C, it's bigger than B, and you can see that, right? So let's kind of look at again in a slightly different problem, right? You can see that I still have the right angle triangle, but I added another part going from the point A, the top point, the point B, and that part is marked with a red. So let's say I drop 3 balls from point A, and each one is going to take a different path. Question is, which one is going to get to B first? All right. So I have a short animation to be able to show it instead of making you guess what it is. So let's see if it is going to show the animation. It's very interesting. It's going to animate the animation and run a couple of times. What you find out is that the red one, the curved one, actually is the one when you drop the ball, actually gets there faster. The one that got the last was actually a straight line between A and B. Because of the velocity, my knowledge of physics is very limited. The velocity and the friction is going to take longer time. And interestingly, when the ball that is dropped from A straight down to this corner and actually gets to the B, it actually gets there faster than the one that went from straight from A to B. So you suddenly realize that the idea about distance I talked about, that this distance, like the triangle I talked about, going down and going under this dot, is actually going to take less time. And you suddenly realize that the whole simple idea that we learned at a very early stage called triangular inequality doesn't always hold. That means some of these two sides in terms of time, so I change the context of distance to time, that actually I'm going to get there to be faster than going straight from A to B. So it is very, very important to, when you look at a problem, think about that, how actually changes the context and what you can do about it. So quickly, brief observation from what I talked about. Distance. So I'm going to use the term metric in a generic way to think about it. It's not always as crow flies. That means when you go in a straight line, sometimes we call as crow flies or Euclidean distance. If you are thinking in terms of mathematics, you don't have to remember that. And as I said, the triangular inequality may not satisfy sometimes. So other interesting thing, the efficiency doesn't necessarily mean shortest distance. So we have to kind of think about efficiency in different contexts as we look at the problem. Let's look at another example of distance before I go further. Suppose you want to compare two documents. You have two documents in your hand, you want to compare them. And so the question is that, are they similar or very different? Okay. And if it is similar, how similar are they? You want to find it out. So can you use the notion of distance in a different way to look at this problem, right? So consider a simple document. So to make it simple, I have only one document, they call it. I have only two words in the document, Koloinu Jua, okay? And I also have a second document where I mistyped and put the word Koloinu twice. So it will be Koloinu Jua. So if you show it to anybody, somebody, class 1 or class 2, they can read it, they can say there are two different things. You made a mistake or you have more information is there. So from a document perspective, they are two different documents, right? So can I actually identify that they are different? The notion of the distance in a generic way to look at it. So first, what you want to do is think about the number of distinct words in the document. And typically use simple, at least in English, you ignore articles like A or B because they appear too many times, right? So I have two documents, Koloinu Jua or Koloinu Jua, right? So what I do the word frequency. So word frequency because I have two distinct words, Koloinu or Jua. So document A, the Koloinu appears once and Jua appears once. Good, that's fine. Document B, Koloinu appears twice, 2, and Jua appears once, correct? Very good so far, right? So this is called the word frequency, number of times a word appears in a document. So the question is, can you use this frequency information to find the difference between the document? So let's try to do a little bit of a pictorial thing. So I'm going to represent this slightly different in the corner. I don't know if you've seen it, the same information of the document A and B. But what I'm going to now do is something you have learned in school called the x-axis and y-axis to plot something on a piece of graph paper, right? So what I did, I put x-axis the word Koloinu, and I'm going to mark it how many times appears it, and on the y-axis I have the word Jua, okay? So since in document A, Koloinu appears 1, Jua appears 1, it's like saying that is the coordinate point 1 and 1, because I have two words, two directions. In document B, Colloino appears twice, Joa appears only once, so it's a 2 and 1. Very good. I'm on a coordinate system. I'm looking at two things, two different documents. They are distinct. I can actually identify. So immediate thought will be that should I consider the distance between them as the shortest distance, which is the Euclidean distance or the crow flies? The answer is that in the context of the document, it's actually not a good way to look at the idea of the distance. So those are the two I talked about. Instead, what you look at that from the point of origin on the XY axis and look at those, what is called the line between them, the arrows, which is typically, if you are familiar, there's something called a vector idea. But you don't have to know vector. But basically what you kind of think about is that, how about if I instead look at the angle between them? You know, if they were the same document, the angle would be what? 0 degrees, right? Because they will have 1 and 1 or 2 and 2. But otherwise it will be different. The other beauty of looking at this angle is what? Is that if there is no common word between them, what is going to happen? It's going to be like 90 degrees, basically, right? And so let's say one document that only have the word Colloino, the other document has only the word Joa. But they are completely distinct. One will be 1, 0, the other will be 0, 1. So the angle will be 90 degrees. So angle is a very interesting thing. So I don't want you to know anything about trigonometry or remember anything, but you can now think about the angle from what is called the cosine of the angle. Why? Because cosine of 0 is 1. That means it's exactly same. So 1 is a good way to represent that information instead of a sine. Cosine is a good way to do it. And cosine of 90 degrees is 0. That means there is no similarity. That means great. I can represent the entire information about document between the value of 0 and 1. 1 is the same thing, 0 is actually too far. Okay, that's what we know. And actually this cosine thing in a generic way, I can write it, the distance formula this way. You look at the frequency of A times the dot product of frequency of B, and then you look at the magnitude of that A and B. And so what you see there, you don't have to remember the calculation. Only thing you need to know right now is that the result of it. What I got is the 0.94868. And we know there's enough commonality between those two documents because the same two words appears, for example, but their frequency is different. So it is not 1, it's not going to be 1, but it's close to 1, 0.94. That means they're fairly similar. It's a very nice way to kind of context to the distance. The other thing here you have to realize that we use this distance differently. 0 actually means being far apart. 1 means they're close to each other. Very interesting way to look at that, right? And why this is very, very interesting and important is that when you look at that, I could do it for 2 dimensions on a picture, but let's say I have a 10 words, 100 words, 200 words. I can use the same distance formula because I can note it what I call as a vector, and it doesn't matter whether you have a million words in a document or whatnot, you can actually look at those two together by just looking at the idea of the angle. Very, very powerful, simple concept. So I want you to think about that in terms of what I talked about there. So let me summarize a couple of things so far. Sometimes we don't see how to approach a problem. We just don't know what it is. Sometimes it's because of our upbringing, my education, it stops us from looking at the problem from different angles. And so to be able to see what exactly is going on with this kind of a particular problem. So this is where I believe it is very important to have imagination. We're not all of us are artists in the sense of drawing pictures or painting or what it is. But I think the imagination in my opinion is extremely important because imagination can take you to think about a problem very differently. You might think it one way, another person can look at it another way. And that kind of a confluence can actually bring some very important new things, new products to the mind. The other important thing is the abstraction of the important. Abstraction doesn't mean complicating a problem. I want to make that very clear. Abstraction only means that can I represent the problem in a simpler way actually, so that I can see what is going on with the particular situation or the problem. Okay, so the angle is a simple idea, right? That's the abstraction idea just by looking at the frequency of in terms of distance. So now if you combine that abstraction and simplicity is important to get a handle what we call solving a problem. And the other beauty of looking at from a simplicity point of view and abstracting a problem is that you can take an extremely complex problem, you can simplify it so that you can understand and solve something simpler, and then you start adding complexity to the problem. So it's not the other way around. That's, at least for me, that's not how I look at a problem. Because I know all kinds of problem or societal problem, everything is very, very complex, even on anything doing on a computer. But if I always get stuck on that, I will never be able to get to what my destination, where I want to go there. But if I can simplify, I can still keep adding complexity to the problem and try to solve it. So next, I got the distance I talked about, gave you some ideas about it. Next, I'm going to go to what is called a graph. And you may ask, do you mean a graph paper? The answer is no. Not about graph paper. And I know I showed a coordinate to explain something to you, but let's talk about what graph means. Okay. So here's a picture of Assam. I'm showing it to you, that you see it. And as you can probably guess, although it is not marked, the red marker on that is Vishwanath Sariyali. Of course, I have to pick that. That's the center of the university as of today. And in the honor of Ripunjoy Tamuly, that I've been able to give this wonderful, I have this opportunity to give this presentation to you. So what I want to do is that I'm going to add a couple of more cities in Assam. Okay, see that I'm going to circle them, including, of course, Vishwanath Sariyali. Okay, so what you got here is that I marked Guwahati, Nagaon, Tezpur, Jorhat, Dibrugarh, and the one that you'd see marked no name because Google Map didn't pick it up, that's of course Uttar Lakhimpur, North Lakhimpur, right? So what I'm going to do now is I'm going to draw, you will notice it, I'm going to draw lines between them. And what I did, I connected Guwahati to Tezpur, Nagaon to Tezpur, Tezpur to, Vishwanath Sariyali, and so on. All right, so next what I'm going to do, I'm going to get rid of the map so I can look at these things I actually represented. You see it there? And this is what we call it is called a graph. Graphs is actually two things only in there: nodes, which are cities that I just talked about, and links here, what are the direct connections between cities. So if you know what I'm talking about, you will suddenly realize that not every city is connected to everyone directly. You can go to another one. For example, I can go from to go to Jorhat, I can go from Guwahati to Nagaon to Jorhat, for example, right? So let me enlarge the picture a little bit because it's easier to see what is going on there. So what I did, I actually put distance in kilometers for all the places between, where it is directly I'm connecting it. You can see that Guwahati to Tezpur, if I go directly to the North Bank, 176 kilometers. Guwahati to Nagaon is 122 kilometers, and and I put all the numbers down. So let's say I want to go to Guwahati to Dibrugarh. And by the way, I have done that many times as a young with my parents. More Aita Dibrugarh আছিল, গতিকে দেউতাৰ লগত আমি সদায় মানে সামাৰত যাওঁ আৰু আইতাৰ, গতিকে so this is a very favorite route for me, going to Nagaon to Jorhat to Dibrugarh. So if you look at Guwahati to Nagaon to Jorhat to Dibrugarh, to make it as easy, I added up the number, and you see that it comes to 446 kilometers. So conceptually, you can also go to Guwahati to Tezpur, Vishwanath Sariyali, North Lakhimpur to Dibrugarh. Of course, you have to cross the river over there. The distance is 522 kilometers. I can also go Guwahati to Nagaon to Tezpur all the way to Dibrugarh also. That's actually slightly less, 515 kilometers. Now, if you ask anybody that if you're going between Guwahati to Dibrugarh, they will say, no, I will always go via Nagaon and Jorhat to there because it is faster and what, And so the question is, what happens is, okay, sorry, before I go there, there's one more thing. Yeah, that's what it is. Now I'm going to put the time in there. So what I did, I went to Google Map. And what I did, I put, assuming that all of us are starting at 8 p.m. They are in India right now on today, I look at the estimate of the time for how long it is going to take to go between any of the two places. I put the time in there. But they give a window. If you go to Google Map for looking at a distance, give a time window, say 2 to 3 hours. So I picked the average value to make it simple. Remember I talked about simplifying a problem? So I said, I'm going to just put the hours there and minutes in there for each of those places. And so one thing you realize is that Guwahati to Dibrugarh is 11 hours 5 minutes. Hope I got my numbers right. If I go through the other routes, 12 hours 15 minutes and 12 hours and 2 minutes. The one interesting thing you'll notice that many of you know that because you drive, that Guwahati to Tezpur, if you go through Nagaon, you're actually going to get there faster than if you have gone to the North Bank, you know, and you can say complain about that because of the road condition or not, but you suddenly realize this is also again where the triangular inequality doesn't hold, right? That's what we learned earlier. So the question is that, you know, can we North Bank route be faster? Of course, it could be faster. You could make, you know, multi-lane, you know, roads are being constructed and improved. It's possible that, you know, there's more congestion. And something I did not consider into the problem is that going through the city or depending on how the route is done, there are also further delay possible. And so, you know, you cannot actually rule it out going to the North Bank, you know, that someday maybe if you want to go by a train, fast train might be there, and possible to do that. So that takes me to talking about the metrics or the distance as a generic word, and then adding it to what is called a goal. So it's very important to understand, distinguish between metric, what I talked about, and the goal. So metric to consider distance, time, I already talked about that. And how about yes, you could do a rest stop to eat something. You can actually account for that in the problem. You can account two different ways. One is that you can actually put it in the node, or you can put in the link in terms of the time, add that information there saying that, okay, I'm going to wait 30 minutes to it. So this link actually, although it was 1 hour long, is going to take me 1.5 hours long because I'm going to stop at a place and eat it. So you can actually simplify the problem that way and look at it, right? Okay. Goal actually means something different from the metric. Goal says that how long, what's the travel time and how long it is going to take. I gave the example of going from Guwahati to Dibrugarh, right? So Guwahati to Dibrugarh is actually going to what I know because it's not directly connected, but I can go through this graph to be able to get to where I'm trying to go. Very good. So we're at a good point right now. So what's the beauty of a graph representation? You can abstract the problem, okay? You can do nodes and the links. And not only that, you can add complexity another way. You can add more nodes. You want to put Mongolia on the map, you can put it there. You want to put Bukakhat on the map, you can put it there. You can actually make the problem, you know, the more detailed, more granular you want information to capture, you can do that. But being able to do a simple way to represent actually takes you somewhere. Then define the appropriate metric. We're going to look at that and define the goal we talked about. So what I'm not going to talk about how actually you can solve the problem. You know, on a small graph that I gave, Dibrugarh to Guwahati, I can actually add up the numbers in my mind and calculate. But there are algorithms like Dijkstra's algorithm that actually allows you to do it. And the other beauty of these algorithms are that shortest path algorithm we are called is that you don't need to worry about triangular inequality. You just define it as a graph and actually let it solve it. And you can prove it extremely fast. You can have 1 million nodes. You know, for example, look at simple idea like, you know, many of you use Facebook. I'm connected to you on the Facebook to say, for example, Manav I'm connected to, I'm not connected to say Tamuly Dangoria. And you can actually compute the whole thing as a very large graph. And in that case, the connection is, you can think about the distance or the metric as only one. I'm connected to Manav Sohoria, one. I'm not connected to somebody. I don't have a link there. And so you can actually then say, okay, how can I get somebody connected to somebody very quickly? We can make that calculation. And that's what it does and prompts it on Facebook, say that, oh, do you want a friend with somebody? And you say, then what happened? You don't even need to look at, you can look at a smaller set of information, other ways to make the efficiency of solving the problem. And so I gave you an example of that. The same idea is applied for circuit design on the chip for computers, for example, because there are a lot of connections on a computer. So next thing I'm going to do is I'm going to go from graph to network. Okay, I always make a distinction between graph and network, but a lot of people do not, even in our community. I'll tell you why I try to make a distinction. To me, going from graph to network is the biggest distinction is the traffic. Traffic is something I have not talked about so far. I have only talked about the time, but not the traffic. So usually, general context, we talk about traffic, like traffic is very bad today, it took me longer time. Traffic was not very bad yesterday. And we kind of do it in a generic way, use the word, but we can actually quantify the way to look at the traffic in certain ways and capture it into the graph problem. So usually the best way to look at the traffic is many ways you can do it, but you can look at traffic as a rate. For example, number of cars per hour on a road. So you have a 2-lane highway going on one direction, there are 2 lanes, like the Horaigat Bridge, there are a couple of lanes there and additional lanes they added. Then what happens is that you can actually look at that information in terms of how many cars goes per hour. So you may have a 60 cars going per hour. So since 1 hour is 60 minutes, that means what? On average, 1 car per minute is going. So it's always good to actually look at that information with very smaller granularity of time. So look at the second. So that means 1/60 cars are going per second. So it's good to look at that information in a smaller amount of time. Then you realize that I have 2 lanes on a highway, but it's actually at any time on a very particular instant of time, 1/60 is actually using it. The capacity is not used at all. So that leads me to talk about what is called the capacity. Is that I already gave you an example, number of lanes on a road. That's the capacity. On the internet, the capacity, many of you are familiar with those terms nowadays because you computers and whatnot for anything you do, megabit per second or gigabit per second. Okay, so Mbps or Gbps. So I want to make a distinction between your bytes in terms of a file size, again, the rate. Remember, this is rate because I'm looking in terms of time per second, right? So how much faster I can transfer something, how efficient am I in trying to do that? The question is what happens when you convert traffic and the capacity to a problem? Okay, so I'm adding something more interesting. Here's a very nice, simple formula. Okay, so it says the delay, the time it takes, actually, there are many other complicated formula. I picked a simple one to illustrate the idea here, is that the depends on the 1 over the quantity capacity minus the traffic. So the capacity is fixed. So number of lanes that you have. The traffic is changed depending on the time. So in a sense, the traffic is only the variable that we have. So let me try to illustrate a simple picture of what it means. First thing you notice that if traffic is exactly equal to capacity, my denominator is going to be 0. So 1/0 is infinite. That means it's going to take a long time. That's what this curve is actually showing, that if traffic reaches to the capacity, then you are going to get to a point, it is going to take for a long time. There was a situation that happened to me one time. It was Magbihu Uruka. So I want to go from South Bank in Guwahati to IIT area to Osaklanta area. And we said, okay, we're going to go. And I did not realize that everybody in Guwahati leaves the town to go to where they come from for the Magbihu celebration on the Uruka Day. And so at that time, I think 2016, the second bridge was not ready yet, if I remember correctly. And so it took me a very long time to cross the Horaigat Bridge, for example. That's your capacity and the traffic because it's back-to-back cars, and you are going to have essentially what we mathematically call it infinite delay, right? But if you go to the middle of the night, not much traffic, your delay is going to be very small. So the very interesting is the behavior of the delay or the time is actually non-linear. It's not linear. That means you increase the capacity. This is something we know. We observe it all the time when we drive a car, but it's non-linear behavior, right? So very good. So what do we do when we drive? So let's go to this simple graph of the network I'm going to talk about. And this one, what I have, the lines here represents number of lanes. So that means all of these have 2 lanes. Suppose I want to go from A to B. I have 2 ways to go. I go to the north route or the south route, go to C or the D. And which was has the same amount of capacity, right? And so what happens then is that you kind of say that you are driving, you get to the point that is that, you know that both roads are similar capacity. So you are going to just make what I call is a random decision. So take aside other things like there is a good restaurant in, location C, take away those other distractions from your problem for a second, right? Other attractions to other. So you can say that, okay, I'm going to basically do like a tossing a coin. I'm going to go this way. And human behavior in this situation, what we're going to do is that roughly 50% would go to A, C, B, and other 50% is go to A to B. The solution is actually optimal because of the way this topology, the network is there. And so 2 lanes there. Now say we construct a new road that connects A to B directly together. And A to B now has 3 lanes because maybe your capacity is really, really growing. It's like the Brahmaputra, the Horai bridge I talked about. Adding the new bridges, new bridge with lanes was what? To be able to relieve the congestion or the delay from the traffic, right? So sometimes you do it. So another way you can think about it is that originally I have 2 units of capacity on the north route and 2 units on the south route. So I had 4 units of capacity total. Now I added 3 units of capacity to the by directly connected. I'm at 7 units of capacity I have. Essentially, I said, okay, I increase the capacity of the network. That means my delay is going to go down into the network. That's the whole idea. But human behavior is really funny. When you see there is a direct lane and it says that, oh, there are 3 lanes there, we're going to all basically start taking the direct road from A to B instead of going to A to C or through the A to D there. And so what I did, I just used the formula I showed you. You don't have to remember the formula. I just showed you the computation. So let's look at what happened. Let's say the capacity is traffic load I'm doing as a percentage, so it's easy to actually see it instead of the rate right now. The traffic load is 25%. That means, remember, originally I have only 4 lanes instead of before adding the 3. So on the middle column, I'm only going to calculate assuming that there's no link between A and B for a second. So since I have a 1 out of 4 lane, it's 25% of the capacity. Basically, I'm using it up, right? And so 1 out of 4, if I split it up, 0.5 goes this way, like a coin toss I talk about. 0.5 goes the way through the south route. So if I look at 1 over 2 minus each route, the delay is going to be on some abstract value as a 0.66. Now, if I add the direct link there, because I have 3 and total load is still 1, I would have actually gone great. I would have gotten in 0.5. That means what? It takes me less time to go there. Very good. People come, they said, okay, I have 3 lanes, I'm going to drive it. Let's go to 50% load. But something interesting happened. 50% load, what we found out is that actually the delay, if you have gone or north or the south route versus the middle route to AB is actually the same. And you go to the 60% of the capacity, you suddenly realize that if everybody started going on a direct path, that the delay is going to be higher, 1.66 as opposed to 1.25. So this is very, very interesting. This is called a selfish behavior. We always are interested in efficiency and optimal way to do it, but we also, as a human being, we have what is called a selfish behavior. And this whole idea about the delay actually goes to somebody pointed out called Brazes paradox in 1968. So I want to give you a very important connection to here to what is called a social cost. So Brazes cost says that if you see something better, what it is, as a human being, we're all trying to actually try to do that, in the road context, and that is actually going to go increase everybody's delay, the travel time to get there. We actually end up taking more time to get there. So I found a paper from Knight in 1912, almost 100 years ago. He wrote a paper called Some Fallacies in the Interpretation of Social Cost. So what is the connection here between those two? So let's see, how am I doing it time? Okay, I'm doing okay. So it will go pretty fast, the last part. And so, so what he kind of said, the same idea that Brazil, what he basically says that sometimes what you want to do, that you know that people are going to take the direct route between A and B because they think what it is. But what you could do is that you can put a toll there. He said that the idea of a toll, there is a toll nowadays in Assam, I know that. But people don't like it. But the idea of the toll is very interesting because it is an incentive mechanism, right? So if I said that I'm going to put an incentive only if the load goes more than 50%. And by the way, this happens in the US in many roads I have traveled. They will only have it when the load is very high. You only pay toll, but other times you don't pay a toll on it. So what is the beauty of that? When you hit the toll, some of us will say, okay, I'll still take it, the toll road, because it is, I may be able to save time, but it disincentivizes other people to take the north route or the south route. And overall, we are actually benefiting by that, basically spreading the load that way. And there is a side benefit to that in terms of the goal, because if you collect the toll, you can use that money to contribute back to the society for other goods, right? And that's basically what Knight talks about. Very, very interesting thing about. So, my background in mathematics, as it was said, I never learned in economics as a student, never had an opportunity because of our educational system. But I think economics is one of the most important things that I have acquired over time by attending classes later stage in my life. Basically, what I said that if you want to have really optimal, you have to use the multiple path to spread out the load between those things. So as opposed to fish route, right? Okay, great. So I now go to the last part of my talk, and so you can see that so far I have talked about only traffic between two places. I talk about going between Guwahati and Dibrugarh with the graph earlier, and in this illustration earlier between A and B. Now consider that there is a traffic between any two pairs of nodes. And you know that, all of us know exactly that. There's traffic between Guwahati and Tezpur. Some people are going, there are people going from Guwahati to Jorhat, North Lakhimpur to Tezpur, to Biswanath Chariali, right? So there's people going all over the place. So you never have a network where it is only between 2 points. Only in our mind, we think that, okay, when I drive, I said that I'm the one, as if it is. I keep certain thing in our mind to take a decision, but actually said, oh, I'm going to hopefully get there as fast as possible. And I use my selfish behavior in that context. So this is the map that I showed it before, just kind of illustrate, I showed it again. All the pairs that is there actually happen. So again, I want to clarify, pair is not the same thing as a link. So there is a link between North Lakhimpur and Dibrugarh. People traveling from Biswanath Chariali may go through North Lakhimpur to go to Dibrugarh. That's the traffic between Biswanath Chariali and Dibrugarh. But North Lakhimpur to Dibrugarh has a link. There you're going to link the road there, right? Very good. So I'm going to move to somebody called John Nash. John Nash, there's a book, it was written about him in 1998 called A Beautiful Mind. There's a movie that was made. There's a question about queuing. Please keep this in mind. I'll come back to that in a second. And the question and answer part of it when we get there. Let's see. Beautiful Mind. It was a movie made in 2001. You want to go see it, So John Nash did a very interesting work in 1950 called Non-Cooperative Game. It talks about selfish behavior. And basically says that in a non-cooperative game, each player makes an independent decision. So this is basically that what is going to be the gain for me. So I talked about the road, that what's the quickest way I can get there. That's the one we actually pay attention to. And what is actually gain. And the same thing applies in, say, if you play stock, stock market, so what's going to be my gain? You kind of think about that perspective, right? What Nash actually showed is that even with idea of this independent decision, actually an equilibrium can still exist, because it's not going to be what is called a sort of a fluctuating situation all the time. You can actually reach an equilibrium. It's a very, very seminal piece of work. And John Nash actually got Nobel Prize in Economics in 1994 for this work. So now I go to another person. His name also starts with John. John Wardrop, a civil engineer. He's a British civil engineer studying transportation network, road networks in the 1950s. He wasn't aware of Nash's work when he wrote his paper in 1952, but he came up with what's called, he called it network gains. And he came up with two principles. It's still used in the road constructions around the world. These principles are very, very important. He said the journey time on all routes are actually used are equal and less than those which would be experienced by a single vehicle on any unused route. And so what basically he goes to the idea of the optimal. So you want to distinguish between non-cooperative game that Nash talked about versus what John Nash is talking about. And his definition of equilibrium is that at equilibrium, average journey time is minimum. Okay, so equilibrium is basically in the context of John Wardrop, he was talking about actually the idea of the optimal, as opposed to the selfish behavior or Nash equilibrium we talked about. That is, there's a distinction between selfish routing and optimal routing. Selfish or Nash equilibrium basically said what's good for me, and optimal routing said what is good for the network or what's good for the society, right? So you want to think about that kind of a context to that. So I kind of put one plot in there. I did some work many, many years ago, and basically that said is that we don't remember any of these details here. Basically says that if and this is for a network, not just for a one link, that if the load is less than 50%, the Nash equilibrium, you can only get up to about 1.5 times the optimal solution, because that is we have essentially our independent way or selfish way of looking at it as a cost. Cost is going to be 50% more than an optimal solution, or what's good for the whole thing. And if you even go to 70% load in the network, then you find out that Nash is within 2 times of 2. That means you're going to Nash equilibrium or selfish behavior will cost 2 times what would have been optimal behavior for what is good for all of us. So that means I go to the final topic about the routing in the internet. So they're very similar in some ways, and that's why I use it in my classes and everything. So on internet, what is the traffic? Your web page, you're watching a video, reading a newspaper and whatnot, So I'm going to put certain things in there. The way the technology works, the idea works, is called a TCP/IP protocol. I won't go into the data, but what happened is a web page or a video is broken out into small pieces. We call it packets. And the beauty of the idea of a packet is that you can think about like packets like cars in a road. Okay, packets are going to travel. And packets are routed from a guided principle. It doesn't have an selfish behavior like road network. It does have a tendency to be a selfish behavior because it uses a shortcut routing, but with a twist. And so, so you do some guiding to be able to keep it under control so you can go closer to the optimal solution. So then when they try to route it in the internet, basically try to achieve optimal behavior as close as possible to the for the good. And the other important thing, distinction between an internet routing in the internet and the road network, that the packet travel time is almost instantaneous. We get a web page within a second or so, right? So as opposed to a road, I talked about hours. When you start at 8 p.m. From Biswanath Sarayali to go different places, it took several hours to go. So that context of time is very important and distinguish between these two problems between road network and the internet. Let me see my animation works. So here I got a thing that I'm going to send a message from one place on the, you're sending a message to your ITA, for example, and you're sending it. I put internet as a very simplified way to do it. What I did, the message, I broke it down into packets. okay, and they are going to go through it. Sorry for the sound. I sometimes like to add sound to be able to make a point about something. So what happened? Each of the packets can go to the network in a different way between the origin and to the destination, which is where it is going to be arriving at. And you get there, and one thing happens on the internet, I won't go into a lot of detail because of limit on time, is that you can actually arrive in different order of the packet. So you number the packets in it basically so that when it gets to your computer, your mobile, laptop, desktop, what it is, it actually combines as sequence the packet, and that's what it gives to you. So you can think about this problem again slightly differently. For example, let's say you are visiting your parents. You are three of you, Bor, Maju, and Horu. All of you said that you are going to drive separately. So each of you can take a different route to get to the destination, but your parents know who is the oldest, who is the middle, and who is the Horu, right? So they can actually assemble the idea together, right? So that's sort of way to think about it, but you can each go separately. That's how the routing in the internet works. So here also the route, nothing nodes I talked about. The links I talked about. Basically, I can represent this middle part as a graph or a network because I have a traffic in it, right? So here I'm showing you a very, very complicated picture of the internet. Nobody can actually quickly look at and solve what is going on here. This is called an autonomous connectivity graph. I didn't even show traffic. I just said who is connected to where in terms of a network point of view in the entire world. And this is not even a new picture. It's actually from 15 years ago. It's the reason you see a lot of connection in the middle is that these are core nodes in the network. It's like, think about the map of India. A lot of people go between, say, Delhi to Chennai, Chennai to Mumbai, like that. So there will be a lot more connections there than, if you think about the airplane network, for example, right? So that's why you see. Then you got the things that are away from it. There's somebody in Imphal going there. Think about like that. So you can actually, again, look at this like a pictorially trying to imagine and represent that information, help you to see what it is. You put everything who is actually too far away in the internet on a circle, and then you connect to the network to go to from one point to another. Okay. About the autonomous system. Now, all these pictures I showed you earlier here, these are all our autonomous system. I mark it as a tier 1 ISP, tier 2 ISP. So you are sitting here in a computer, you are actually what is called a jump. We're going to go from one network to another. So it is like a network of autonomous system of network. What is the beauty of this? Going back to the graph idea, you can think about without knowing all the details about a particular network. This where I'm starting with the U3 here, you can see there. And this network, I don't need to know all the detail. For example, you are going to go from Guwahati to Tezpur. You don't know all of the traffic detail or the network within the city of Guwahati. You can say that, abstract it as a one node, one city. I don't need to know how I got from, Dispur to Bhorlumukh or whatever. You don't need to worry about all the detail when you're thinking of the picture of going a longer distance and whatnot, right? So same idea applies to internet, and that way you break out a very complicated problem into simpler problem. That means each of the network does a routing internally, and then they said, I'm going to just take the packet, give it to there, and it's going to hop to the other network. And you can now think about all of this autonomous system to the direction. So here are a couple of pictures I'm showing it. If you're interested, you can go to Topology Zoo. Some of these pictures are very old in the sense that about 10 years old, but I wanted to illustrate it. So the picture on the left is the Tata network. And think about this as a one autonomous system that I talked about, one of those clouds in the previous picture. And this is the ERNet, this is the Education and Resource Network of India, from it's actually about 10 years old picture. And this is a map in the US. It is called the ESNet. I'm showing a simple illustration called an energy science network. So each of you can actually route, each of the network can route it separately and whatnot. Okay, so I am almost, so if every pair of node has the data to send instantaneously, because on the internet, that's what happens, and all of them compute for the network resources. What is network resource? Because it's the capacity of the network, right? what is their goal? I want to get the packet from one person, a client, we request from the server to you as quickly as possible. But I cannot use a selfish behavior, because if I did a selfish behavior, we know, for example, we talked about, that is going to can be a problem. So you want to look at these things, that the goal is that I want to minimize the average deal capacity. Does capacity matter? We want to look at it. So let me look at again the network. I did a couple of other things. It's very simple, hopefully, for you. N is the number of nodes that we know. L is the number of links. I put it there. In this AssamNet, road network, I showed it there. There are 7 links there. Links are built Guwahati to Tezpur, Tezpur to Nagaon, Nagaon to Guwahati. Like that, there are 7 links. And there are 7 Guwahati, Tezpur, Nagaon, Bishwanath, Sariali, North Lakhimpur, Dibrugarh, and Jorhat. And I'm going to introduce one more thing. Remember, I start talking about everybody has traffic. There's a simple formula to compute the pair. So I'll represent pair by P. And the beauty is the pair you can compute from the value of the node. It is n times n minus 1 divided by 2. There are actually 21 pairs of traffic possible in this network when they are competing against each other. So pairs are like Guwahati to Dibrugarh, or Guwahati to Tezpur, Guwahati to Bishwanath Sariali. Again, remember, pairs and links are different. North Lakhimpur to this Dibrugarh is also a pair from a traffic point of view, but it also has a link. So a link can be contributing to but they're not exactly the same information. So remember the nodes, 7, link, the nodes, the link, and the pair. So for a long time, it was believed that when there are traffic between any 2 places in the node, and instantaneous transmission, not on a road network, instantaneous transmission like an internet, we thought that if we can split and load balance, take multiple paths, you go from like Guwahati to Tezpur, the north bank, and I take from the south bank, that it is going to be better for everybody. And that routing, multi-path routing is better. And second thing is that if the network gets bigger and bigger, it's actually even better that multi-path routing is going to be. The very interesting thing when I looked at this problem many, many years ago was that all of this result talk about not the actual optimal solution. They actually talk about optimal solution. Why you do that? When you have an extremely large network, like 200 nodes in a network or 1,000 nodes in a network, 15, 20 years back, it was even very hard to compute it very perfectly. So use an approximate so that you are within, let's say, 1% or 0.1% of the optimal solution. And that's where these results were done. So this problem actually bothered, kind of came to me through my friend, Mikhail Piero, he's from professor at Warsaw University of Technology in Poland. I met him at a meeting, by the way, a chance meeting, you can say, about 25 years back. So saying the deep, there's something going on here. We need to look at this problem. And so he heard something from somebody about 2003 or 4. He told me about it, and we said that okay, it looks interesting. But it kept kind of bugging me that why people, mostly what is kind of disturbing me is why people are saying that it works well when you have we know that road balancing works very well if there's only one pair of traffic, like Guwahati to Dibrugarh. Nobody else is traveling on the road. You split it out, spread it out, you're great. But when everybody is competing for that, then the answer we need. So what happened is that we actually found out a very interesting counterintuitive result. What we said is that everybody just needs to take actually one path. We just said that you just go on this particular path, but only a small fraction of, which is L divided by P, very simple to remember, need to use multiple paths. Second thing we found out is that as the networks get really, really large, no networks, the number of links is more than 3 times the number of nodes. So you go back to here, even the topology I did it for the AssamNet. There, L equal to 8, node is 7. 7 times 3 is what, 21? Yes, 8 is smaller than 20. We know that, right? So it's actually almost 8 is closer to the number of nodes. L is very small, similar to M. So why is that? So I'm going to give you a very intuitive way to look at this. So those who are interested. So if let's say I write out exactly L equal to 3, remember the formula for P, I said P is n times n minus 1 divided by 2. If I look at the L by P ratio and you work out the algebra, you get the result that is going to be 6 over n minus 1. So if n is, let's say, 1,000 nodes or 1 million nodes you are computing, everybody is computing. 6 over 1 million is what? Very, very small fraction. That means everybody needs to take only one path. Only a very small person needs to actually leave the other part, right? So why is this important? Internet do not need to do a lot of internet path when do routing. It actually can save your time for delivering a web page and the video faster. So I'm basically now coming to the end. I really appreciate your time. I think I went a little over than what I planned for, but I want to summarize a couple of things. Summarizing the topics I covered is the metrics and the goal. You want to differentiate it out. Goals can be efficient, but you want to be careful what you mean by efficient. The graphs and the networks are very, very important, and the routing actually takes care of it. I talked about the surface versus optical decision. There's an echo somewhere from. Somebody can mute yourself, please, for a second. Efficiency is in the eye of the behavior. Yeah. So this context applies to social costs. I gave you the idea. So lessons learned. The first thing is that, important thing is to simplify the problem, break it down to something that you can solve. Can you abstract and imagine in your mind what the problem? Can you be like a painter? It's very important. Even on science and technology field, or you need to actually think about the imagination, imagining a problem. Imagining a problem is not being artificial, trying to understand what it is. I always believe writing is very important. Writing doesn't have to be about science, but any ideas you have, movie, write something about it. It makes your thinking and the process much, much faster. You need to think about out of the box. Do not get impeded by your training. I gave the idea of a distance before. Be prepared for countering results. That's what we actually were, even we were not sure that we got the answer. Discuss with others, very, very important. You get ideas, your collaboration matters, and especially for interdisciplinary problems are nowadays very interdisciplinary nature. Something I did not talk about, Professor Jutikona Das Tamuly is a zoologist, I know that. So let's say she wants to think about comparing chromosome about two persons or two species, Can I look at that as a distance problem? How far they are similar or different? You can actually look at that problem. You may not know the answer yet, but you can start talking and say that, let me think about the problem. What matters to you in that particular problem? You want to think about it, right? So a lot of places, and I always say, do not forget common sense. I always got fascinated with routing some 35 years back when I took a course on optimization. I needed to knew about the road network problem, but not internet yet because it was not there. So I said that go with this and what you I talk about Koloinujua at first, and that reminds me of a very famous song by Bhupen Hazarika, Kokai Koloinujua, Margarita Hatoloi. And so sometimes we do know where we actually want to go. But what I want to finish it by saying that not all those who wander are lost. It's a very interesting quote from Tolkien. So sometimes we have to think and wander a little bit to be able to get to a solution. Thank you. I'm going to stop it here.
Thank you so much, sir, for your valuable insights. Your valuable deliberation on the respective topic will definitely give the participants a new perspective to enhance their thought process with the noble ideas leading to the fulfillment of their goals. We shall now start our interactive session. So there is a question on the chat box. The question is by Dr. Sunayana Goswami, Assistant Professor, Department of Zoology, Biswanath College. I would like to read out the question. How the queuing tendency got affected with respect to the measures adopted for shaking the traffic? Sir?
The formula of the delay formula, I gave it to you, actually comes from a queuing formula. The idea of a queuing basically says that you want to think about the traffic as a random phenomenon, or stochastic, we say it. So if you have a random way of arriving, think about cars going on a road, packets coming on the internet, they arrive when you take a decision in a random manner. So basically that has the idea of that trying to actually look at it as a queuing phenomena. And queuing basically said that if you get closer to the capacity of the what it is there, that if your traffic increases, it's going to increase the delay. So that's sort of the relation. And I'm not sure if I exactly answered your question. Let me see if I can find the question, if I lost the context to the question. Okay. Hopefully I answered the question. Shall we go to the next question, please? Because somehow in the chat, trouble filtering out which one are questions for me or other. Okay, I think I saw another question here. Okay, so let me see. Go back. Let me ignore yeah, okay, I saw the question about the queuing aspect to measure adapter shaking the traffic. So I kind of, queuing tendency is the nonlinear behavior. The queue is basically piles up. I already kind of addressed that. Let me see. Okay, there's a question about how data is stored in a cloud. I talked about, but I'm happy to address that question. Data stored in a cloud is basically like your disk. Computers have a disk. So you exactly the same you store it, but you cannot store it in one disk. You have to store it in many, many disks. So disks are also organized in what is called a storage network. So network idea, even in a disk matters. Even there, it has to, once it gets to the cloud is what we call is a data center network, actually. You actually have to move to another network to be able to go to the piece of information. There also the efficiency really matters, and they do a lot of, like Google or Amazon Web Service did a lot of work to be able to try to make that able to do that properly and store it. Our next question was just from Corona Kanto. So just wanted to know the network connectivity. I myself working on senior quality assurance in Microsoft. I just want to know one of my doubt. Is there any software or any kind of way how we can distinguish a fault in a network part locally? Connecting our, I'm trying to put. Finding a network fault on a network part, that's actually a very, very difficult problem. Tools like what is called the old days a ping and a trace route, we can use it. But even though those are sometimes different providers disable it, actually very, very difficult to kind of solve it. This remains a complicated problem on a larger scale. Within a cloud, you can actually have a much easier way because you control the entire network. If you control that entire network, you actually track it. There are other things you can do about the fault is that you measuring traffic is always important. If you expect the traffic to be, let's say, 10% at one point, and suddenly you see somewhere it is suddenly jump up to 80%, you knew that there must have been some sort of a fault potentially, not necessarily because the traffic actually went up. Can we determine network path taken by packet at destination? Yeah, that's where you can do something like a trace route, as long as all of the nodes in the network actually can allow you to get a response back. You actually can find out. In a smaller network, it's possible. And in the old days, when I first started using the internet, we could do trace route to anywhere in the world. It is not blocked nowadays because of security reason. they will block it for you, and you are not being able to actually determine exactly the path you are taking. Other questions? Okay.
So there is one more question.
Please go ahead.
The question is from Mayur Goswami. Does packeting mean breaking down a whole thing into pieces while transferring and then combining it again the way it existed before being packeted when it has been transferred?
Right. Actually, you're right. As I said, if you have a web page, whatever first does is that it breaks it into those small packets, like cars, right? Or you can think about more like a train. You know, you have a train, you have a dabba number 1, 2, 3, 4, up to 10. So that's like your web page. It breaks it into small pieces, and each one is basically sent independently into the network. And once it gets to, nothing is done inside the network to combine them. Only once you get to your destination, your laptop or your mobile is combined by your laptop very quickly by looking at the sequence number. Say, okay, this is and then that's what is displayed to you.
The next question is from Kishale Bhagavati. The question is, if the packages are rearranged upon reaching the destination or goal, will this rearrangement affect the data at last?
Yes. The rearrangement is going to affect not the data, it will affect the time to display it to you. It can be a little bit longer. And this is also where you realize routing is very important. Although you break it down into small packets, send actually like a train, for packet number 1, packet number 2, packet number 3 on the same path, because in the destination is going to arrive at the same order, and your computer takes less amount of time to. It actually takes very minimal time to do it, but still there's a, sometimes your microsecond, milliseconds matter. You actually can save on that and display it quicker. Yeah. Mm-hmm.
Our next question is by Shubhamoy Bhattacharya. How can we deal with the imagination in every moment?
That's very difficult. Imagination every moment, or any problem, I don't try to imagine something all the time. It just it's something I believe that it's a very famous Leonard Cohen said that somebody asked him where the songs from. He said if I knew where the songs come from, I'll go there all the time. So it's imagination or ideas don't come all the time. You think off and on. I never think about the problem 20. Just doesn't work for me. It might work for somebody else. I have to do different things. I do exercise, or I watch movies, I watch sports, different things. Suddenly it pops in your mind. So I always keep the context of Leonard Cohen's that's interesting quote in mind when I think about imagination. It doesn't. Imagination and ideas do not always come all the time, but it will pop in your mind sometime, right? And something different you are thinking about. And I just cannot think about it as something you can do every moment for a problem. I feel like my mind is explode if I try to imagine and solve the problem all the time. So every instant
Thank you, sir. Here, I would like to say one thing, that if the participants want to ask the questions directly, then they can just raise their hand and they will be unmuted.
That is also fine. Yeah, sure. Okay.
The next question is from Dr. Pratiksha Bejborua. Is non-linearity of delay with traffic an outcome of stochastic behavior in the system?
Absolutely, that's correct. It's because of the stochastic behavior. If it is a deterministic behavior, you will never have a non-linear. So what I mean by that if we all go exactly at the same speed in a car, one car after another one, you won't notice any delay on the road. You're all going to, right? But when you try to do overtake and all this part, then you are going to do this kind of stochastic phenomena, and the delay is going to actually show up. So, and if you can control the rate of coming the information to a place, yep, you can actually get, but stochastic phenomenon is what actually causes delay. Yep. Very good question. Yeah.
The next question is from Prasiddha Hajarika. How can students train their minds to think out of the box?
Very good question, right? Do different things. Don't do. I mean, I was always interested in sports, and I still remember before my HSLC exam, there was a professor near our house. He will come and visit my father. I always talk to him in the evening for 3 hours. Nothing about studies, completely no relation to it. And I always was interested in sports and whatnot. And so, to me, I feel like that that doing something different outside the area of what you are allows you to actually think outside the box. That's one thing. Second thing, talk to people outside your field. You might be really good at, you might say that, you have a problem, let's say something about language you're trying to figure. I talk about the document comparison, right? You can do, word about spell, for example. You might have an idea, but you don't know it, but you talk to other people. The other people say that, another person might say, why don't you look at it this way? And which you never thought about. So the conversations to me are very, very important. And that actually fuels the idea of thinking outside the box. So when I say conversation, I really mean listening rather than being advice. I always try to avoid giving. I said that, have you considered these different ways to look at problem? One of my former students, he did a phenomenal piece of PhD work. He will come to my office and talk, and apparently I have a habit of saying something after he tells it something, and I say, he's from China. His English was not very good at the time. And I say that, Dijian, this is not necessarily a bad idea. And that he was not sure whether I said it was a bad idea or good idea. Maybe I meant it is a bad idea, or maybe I actually, because I said not necessarily a bad idea, he thought maybe it was a good idea. So he ended up exploring it anyway, instead of saying that, okay, I don't need to go that direction or look at that way. And actually he came up with a phenomenal piece of work that did this, it's just unbelievable. So I think that, how you treat people, how you give the opportunities to people also matters to think outside the box, I think. And your training, I know idea is much more rigid nowadays compared to the time we went to school, and we have a lot of freedom to do different things. And I understand that, but still there's opportunity to do that. Okay, next one, please.
Thank you, sir. One of the attendees, Abhishek Puya, is asking, sir, I was really moved when you spoke about how oftentimes our upbringing and education stop us from finding the best route. My question is, can packets be compared to the torrent download, where the main file gets downloaded in segments all at the same time? Also, on a different note, in what manners do we need to approach this subject for a better understanding about routes?
Mm-hmm. So torrent, for those who are with a torrent, is that file transfer that you can do, for example, from multiple locations. What happened is that this is again very interesting. We can say that, okay, let's say there is a big, large file, a movie you want to download. It's only in one place, right? If it is one place you're download, you're going to almost do sequentially. You are going to compare, get sequentially. I mean, you'll still packetize the idea, the information, but you're going to transfer it sequentially. What happens instead of that? I make a copy of the movie in multiple, so 10 different sites, keep it different. And when I'm as a client, that means my laptop or desktop, that I am trying to access it, what I do is that I know that 10 different sites have different information. I'm going to tell them that you give me from the 1/10 of this thing, another plus I give it to 2/10, the third part they give him the third tenth of it like that. And I basically do what is called a parallel way to be able to do it. By doing it parallelly there, you can actually transfer it. But when I do parallelly, remember, your now source and destination change. You have multiple destinations. Do not mix it up as a destination because they have 10 sites, right? So each one is still transferring it. You have to do a little bit more work on reassembly, but you can do it on the client, but you actually can download there because there might be more capacity available on different locations where the file is distributed and stored. Hope I answered the question. So.
Okay, due to time constraint, I shall pick the last question. It's by Mayur Goswami. Being a professional in your field, I would like to ask how related is the traditional or academic education from real life problems, or is there any difference?
Well, real life problems are very from academic education, honestly. You know, people who make products, you know, they have to think about many things. But as I said earlier, you know, being able to abstract and simplify a problem is a good way to start it. That doesn't mean that solves the real life problem, but it allows you to get to what do you actually try to solve it. You know, Sohoria, he has been doing some amazing amount of work on flood modeling. You know, he has something in his mind, in his vision where he wants to go. And if he says that I'm going to do it today, it's not going to happen. You know, he knows that I knows that. It's, you know, something like what we call is, in Assamese, there is a phrase we call bhukute kal napoke. Exactly, sort of like that. So you have to start to say, how can I break it down into smaller problems, simpler problems, abstract it, simplify it, and solve those different pieces, and keep adding to it to where you want to go there. And many cases, even in a real life problem, you don't have to exactly have the exact situation. You can do a fairly close one and get a better and better idea about it. And so you know, real life is and whatnot, but there is always a distinction between what is and from our way of our academic training it is. And I believe a little bit of more our educational system, I believe it's important to have a little bit of practical experience, very you can do it early on. I also believe that economics should be a required course in class 7 or class 8 level, because economics drives everything. Doesn't matter what I'm talking about, whether you are a cloud provider, you are doing internet, airplane, everything. You may know technology, but economics is what I realize is very important. You know, so I wish it was required course at class 7. And I would hope educators who make policy decisions look into that. The other thing I believe is, for me, really benefited that I took it. It was the first year they introduced in our SSLD exam was the social studies. I thought I learned a lot from social studies. You know, I realized that at that time when I took it in metric, but it was the most useful thing I learned. Not science courses, more like mathematics courses. I forgot many things. What that allowed me was that I could talk. I have met people from all over the world. I can actually bring up a topic because I learned something basic from social studies about different parts of the world, different societies, civilizations. I meet somebody from another part. I said, "Oh, I know about this. You know what is going on there. I can actually start a conversation." And nothing has been more valuable in my life. So.
Thank you so much, sir. We shall end our interactive session now, and sorry to all those attendees whose questions have not been addressed. It's all because of the time constraint. Now I shall hand over the rest of the session to Shibashri.
Thank you, Antaripa Bora. Thank you very much.
Welcome, sir. Welcome.
Thank you so much, Ms. Antaripa Bora. We have almost reached the end of today's memorial lecture, but before we conclude, I would like to request the professor in charge of Ripunjoy Knowledge Hub, Ms. Jutikana Das Tamuly, to address the gathering with a thanksgiving.
25 নৱেম্বৰ আমাৰ বৰ সাহস বিশ্বনাথ মহাবিদ্যালয়ৰ বাবে আঘোণৰ নিয়ৰখনা 25 নৱেম্বৰৰ এই সন্ধিয়াটোৰ আছে এক স্বকীয় মহিমা ই আমালৈ কঢ়িয়াই লৈ আহে এক সুকীয়া বৈভৱ এই ঐতিহ্য আৰু সোণোৱালী বৈভৱৰ বাটেদি এটা দশকতকৈও অধিক কাল আগুৱাই আহি RKHে সমৃদ্ধ কৰিছে আমাৰ এক সুকীয়া বৌদ্ধিক চেতনা চহকী কৰিছে ন বিষয়ত আমাৰ জ্ঞানৰ ভঁৰাল আজি আকৌ এবাৰ আকাশৰ তৰাবোৰে ছটিয়াই দিলে পুৰণি সপোনবোৰ পোহৰ কৰি তুলিলে ৰিপুঞ্জয় নলেজ হাবৰ চৌপাশ জোনাকীৰ পোহৰত মায়াময় হৈ পৰিল এই হেপাহৰ সন্ধিয়াত জোনাকৰ নিৰিবিলি ছাট খোজ দিবলৈ গৈ মই প্ৰথমেই শলাগ ল'ব বিচাৰিছো মহাবিদ্যালয় কৰ্তৃপক্ষৰ বৰ্তমানৰ ভয়াবহ মহামাৰীৰ বাবে সামাজিক দূৰত্ব বজাই ৰখাৰ সময়ছোৱাত মহাবিদ্যালয়ৰ NICM MHRD প্লেটফৰ্মৰ পৰা অনলাইন যোগে বক্তৃতা অনুষ্ঠানটি পাতিবলৈ অধ্যক্ষ মহোদয়ে লোৱা সিদ্ধান্তৰ বাবে আমি সকলোৱে মহোদয়ক আন্তৰিক ধন্যবাদ জ্ঞাপন কৰিছো ইতিমধ্যে বহু গুণী জ্ঞানী শিল্পী সাহিত্যিক ৰাষ্ট্ৰীয় আৰু আন্তঃৰাষ্ট্ৰীয় খ্যাতিসম্পন্ন বিজ্ঞানী শিক্ষাবিদ সাংবাদিক আদি সমাবেশত ধন্য হৈছে ৰিপুঞ্জয় নলেজ হাবৰ মজিয়া এইবাৰো তাৰ ব্যতিক্ৰম নহল এটা কথাত আমি আজি বিৰাট সুখী যে আজিৰ পৰা 30-35 মান বছৰৰ আগতে এই বিশ্বনাথ চাৰিআলি ঠাইখনত কম্পিউটাৰৰ বহুলভাৱে প্ৰচলন নাছিল কিন্তু তেতিয়াই ৰিপুঞ্জয় এটি জন্মদিনত আমি এটা কম্পিউটাৰ জন্মদিনৰ উপহাৰ হিচাপে যাচিছিল তেতিয়া ৰিপুঞ্জয় আছিল মাথো নাৰ্চাৰীৰ ছাত্ৰ কিন্তু কালৰ ফুটত সি নিজে নিজে তাৰ বয়সৰ জোখাৰে কম্পিউটাৰৰ ইমান জ্ঞান আহৰণ কৰিলে যে ভাবিয়ে আচৰিত লাগে আৰু আজি এই 25 নৱেম্বৰৰ দিনটোত এজন বিশিষ্ট কম্পিউটাৰ বিজ্ঞানীয়ে ৰিপুঞ্জয় সোঁৱৰণী বক্তৃতা প্ৰদান কৰাত আমি গভীৰ আত্মসন্তুষ্টি আৰু অত্যন্ত গৌৰৱ অনুভৱ কৰিছো আমাৰ পৰম সৌভাগ্য যে USAৰ NSFৰ প্ৰগ্ৰাম ডিৰেক্টৰ আৰু ইউনিভাৰ্চিটি অফ মিছৌৰী Curator's Distinguished Professor খ্যাতনামা ইণ্ডো আমেৰিকান কম্পিউটাৰ বৈজ্ঞানিক অধ্যাপক দীপাংকৰ মেধি ডাঙৰীয়াই আমাৰ লগত কোনো যোগসূত্ৰ নথকাকৈ আমাৰ বক্তৃতা অনুষ্ঠানত বক্তৃতা দিবলৈ মান্তি হোৱাটো মহাবিদ্যালয়ৰ পৰ্যায়ৰ ছাত্ৰ-ছাত্ৰীৰ উপযোগী হোৱাকৈ তেখেতে ডেটা ট্ৰান্সফাৰৰ যি এক মনোমোহা বক্তৃতা আগবঢ়ালে তাৰ বাবে আমি কৃতজ্ঞ থাকিম এই যোগসূত্ৰত বিশেষ সহায়ৰ হাত আগবঢ়োৱা IIT দিল্লীৰ ডক্টৰ মানৱেন্দ্ৰ চহৰীয়া দেৱলৈ থাকিল আমাৰ হিয়াভৰা আশীৰ্বাদ আৰু শুভেচ্ছা তেখেত আমাৰ ইয়াং জেনেৰেশ্যনৰ বাবে এক বিশেষ ইনস্পিৰেশ্যন হৈ ধৰা দিছে আমাৰ দৃষ্টিত জীৱনৰ অৰ্থ কি মহাপুৰুষ শংকৰদেৱ বিৰচিত কেদাৰ ৰাগৰ এটি সুন্দৰ বৰগীতেৰে জ্যোতিমালা বৰগোহাঁইয়ে সংসাৰৰ পৰম সত্যক উপলব্ধি কৰিবলৈ আমাক মুহূৰ্তৰ বাবে হলেও বাধ্য কৰালে জীৱনত যাতে তুমি সুৰৰ ৰাগত বলিয়ান হৈ আৰু আগবাঢ়ি যাব পাৰা তোমালৈ থাকিল আমাৰ অযুত আশীৰ্বাদ এই বক্তৃতা অনুষ্ঠানত যিসকল আদৰণীয় ব্যক্তিয়ে যোগদান কৰি অনুষ্ঠানটিক মহিমামণ্ডিত কৰি তুলিলে সেই সকলোলৈকে ধন্যবাদ জ্ঞাপন কৰিলো ছাত্ৰ ছাত্ৰীসকলৰ নতুন কথা জনাৰ উৎসাহ আৰু উদ্দীপনাই আমাক যথেষ্ট অনুপ্ৰাণিত কৰিলে। প্ৰতি বছৰে আমাৰ কাষত থিয় হৈ আমাক সাহস যোগোৱা ৰঞ্জিত, দেৱাৰুণ, ইন্তি, অৰূপ, পাৰ্থ আৰু মোৰ সহকৰ্মী ৰাহুল, সুনैনা এওঁলোকৰ অবিহনে বক্তৃতা অনুষ্ঠান আধৰুৱা হৈ থাকিলহেঁতেন। অনুষ্ঠানটোৰ গুৰু দায়িত্ব মূৰ পাতি গ্ৰহণ কৰা মোৰ ভাতৃসম সহকৰ্মী ডক্টৰ ললিত বৰুৱা আৰু হোষ্ট আৰু কো-হোষ্ট হিচাপে মোৰ ভগ্নী সদৃশ অন্তৰীপা বৰা আৰু শিৱাশ্ৰী হোজাই চাই ইমান ধুনীয়াকৈ আঁত ধৰি অনুষ্ঠানটো আগুৱাই লৈ গ'ল, তাৰ বাবে আটাইলৈকে আমাৰ আন্তৰিক ধন্যবাদ আৰু শুভেচ্ছা থাকিল, যাতে তোমালোকৰ জীৱনৰ সকলো সপোন সাৰ্থক হয়। আমাৰ প্ৰাণী বিজ্ঞান বিভাগৰ ভাস্কৰ দাসে আগবঢ়োৱা সেৱাৰ বাবেও মই শলাগ লৈছো আৰু আন্তৰিক ধন্যবাদ জ্ঞাপন কৰিছো। বেলিৰ দৰেই হালধীয়া সময়বোৰ বুকুত গুজি তেওঁ আঁতৰি যোৱা সুতীক্ষ ঋতুৰ পাছতো কলিজাত ৰ'দৰ নিশ্বাস ঘনালাভ। স্মৃতি নহয় তেওঁ, একোটা দুখৰ স্তৱকো নহয়। সি মোৰ সপোনৰ সহচৰ, জীৱন যুদ্ধৰ সহযোদ্ধা। ৰোগ আৰু যন্ত্ৰণাৰ শৰে বুকুত শালি পেলালেও যি আশ্চৰ্য অকাতৰ তেওঁ কেতিয়াও নেহেৰায়। কুঁহিপাত কেঁচা হৈ তেওঁ সমস্ততাক আৱৰি ৰাখে। দুখ নহয়, সুখ নহয়, অমৃত অনুভূতিৰে তেওঁ বিয়পে বুকুৱে বুকুৱে মোৰ পৰা আপোনালৈ সহস্ৰজনলৈ প্ৰেৰণাৰ স্ৰোতস্বিনী ধাৰা হৈ চিৰকাল। ধন্যবাদ।
Thank you so much, ma'am. Today's session was a very interesting and a mind-boggling one. But unfortunately, we have come to the end of our today's event. To our honorable resource person of today's event, Professor Dipankar Mehdi sir, and keynote speaker, Dr. Manavendra Saharia sir, all honorable dignitaries, and also to all the attendees of today's event. We once again, on behalf of the Viswanath College fraternity, would like to extend our heartfelt thanks for providing us with your precious time and joining us today. We will now like to conclude today's event with a silent national anthem. And also, I would like to request our respected resource person of today's event to kindly transfer the presenter position to our host, if you can, sir. Ready, sir? Can you hear me? Sir, can you please transfer the presenter role to our host?
I am trying to do that. I don't think I have.
Please click on IIC MHRD Viswanath College and
Okay.
right click and you will see an
I
option
got it.
for.
Okay, got it. It should be okay now. All right.
Thank you so much, sir. Thank you so much, sir. Ready, sir? We will now like to conclude today's event with a silent national anthem. And for that, I would like to request all the attendees to stand where you are seated in honor of the national anthem.
Thank you once again to each one of you for joining today's session and making this event a fruitful one. So here I would like to conclude today's memorial lecture and stay safe. Thank you.
Thank you.
Thank you.